This is confidence intervals to estimate the mean when the population standard deviation is known, part 2. So we had completed example 1, but I wanted to review what we said about it. So battery manufacturer claims that the lifetime of a certain battery has a population mean of 40 hours and a standard deviation of 5. This is a claim. That means it might not be true. We let X bar represent the mean lifetime of batteries in a simple random sample of size 100. So if the claim is true, if the mean is really 40, what's the probability that X bar is less than or equal to 39.8, that the sample mean is less than 39.8? And we did normal CDF and we found that it was 0.3446. So if the mean really is 40, the probability of a sample of 100 having a sample mean of 39.8 is pretty plausible, because the probability of it happening is much greater than 0.05. It has to be unusual, it has to be less than 0.05, and this is a lot bigger than 0.05. It's 0.05 is 5%. This is 34%, basically. Now, if the claim is true that the mean really is 40, what's the probability that the sample mean, they should actually say X bar, that the sample mean is less than or equal to 38.5. So we calculated that and found that to be 0.0013. That's a very small probability. That means the chance of that happening is really slim. If the true mean is really 40, it is very unlikely that you would have a sample of 100 batteries that have a mean lifetime of less than 38.5 hours. So based on our answers, if the claim is true that the mean is 40, then it's definitely unusual because it's less than 0.05. And so it says if the sample mean lifetime of 100 batteries were 38.5 hours, would you find the manufacturer's claim to be plausible? No, because if it's really 40, this is the probability of that happening, of it being 38.5 or less. It is less than a 1% chance, so it's really not plausible at all. So we are going to take that's kind of part of the big picture. So when we find a confidence interval, it essentially means we're finding all the values for the population mean that would not make our sample mean unusual. So over here, a sample mean of 38.5 is unusual. 38.5 is not a plausible sample mean if the true mean was 40. So we don't want anything in our confidence interval that's going to be unusual. So for instance, in the sampling distribution above, that we just talked about, we have a good idea of how likely it is that a sample mean will fall into a given range based on the empirical rule. We know that there's a 68% chance that the sample mean is within 1 standard deviation, 95% chance that it's within 2, and 99.7% chance that it's within 3. For any other probabilities, we can calculate with our calculator. All right, example 2, confidence interval. If you get a sample mean of 23 and you know that the sampling distribution has a standard deviation of 1.5, this is when we take the population standard deviation divided by the square root of n. Find the 95% confidence interval for the population mean. So the population mean is unknown because we are trying to find the confidence interval to estimate the population mean, so we don't know it. But we do know that whatever it is, our sample mean is 95% likely to be within 2 standard deviations of it. So 2 standard deviations equals 3 in this case, because 1 standard deviation is 1.5, 2 would be 3. So if we took our point estimate, which is our sample mean of 23, and we subtract 3, we get 20. If we add 3, we get 26. So our confidence interval would be between, to estimate the mean, would say that the mean is anywhere between 20 and 26. We can write it this way. or we can, or this way, really, with the plus minus, or we can write it this way. Either is acceptable for a confidence interval. The point estimate is the sample mean, and the margin of error that we found, the 3 and the -3. Basically, the way you find that normally is you take the standard error, which is the standard deviation over the square root of n, and you multiply it times the number of standard deviations that correspond to whatever the confidence level is. Now, sometimes that takes a little bit of calculating because it's not always something obvious. So how do we find a confidence interval? We're going to do this in 3 pieces. The first thing you do is you find out the point estimate. For everything that we're doing with this particular section, that's going to be the sample mean. Okay, later in a later section, later video, we're going to do confidence intervals to estimate proportions. So the point estimate in that case would be a sample proportion. Then we're going to find our standard error, which is the standard deviation over the square root of n. And then we're going to find the z-value that corresponds to the confidence level. We call this value a critical value. There's a notation that will pop up in a moment. There it is. It is z. This symbol here is a lowercase alpha over 2. This is just a notation. We write it like this, just like what is over there. This does not mean that we need to divide anything by 2. We're not dividing by 2 in the formula that's going to come up in a moment. This is just the notation for the critical value, the z-score that corresponds to the boundaries for the confidence level, and I'll show you more about that in a moment. So then for the confidence interval, we take our point estimate and we add or subtract the margin of error. So this right here is the margin of error. The margin of error is the critical value times the standard error in this particular case. So now we have a formula. Our point estimate is our x bar plus or minus the margin of error, which we find by multiplying the critical value, z alpha over 2, times the standard error, which is the standard deviation over the square root of n. Sorry that got left off. All right. So how many standard deviations do you need to go out to cover, let's say, 90% of the data? So basically what we need to do is we need to find the z-scores for that. And that's where what we learned in the previous chapter kicks in. So 90% of the data is here. That's 90% of the data. We want to find the boundaries for that. Now, we're finding z-scores. So that means we're talking about on the standard normal curve. So if we know that the center is 90%, we can find those boundaries by finding, first we need to find the other percentages. So remember, the whole curve is 100%. So if the center is 90, that leaves 10% on either side. So that means the left should be 5% and the right should also be 5%. Now, remember, to find a number, in this case, z alpha over 2, which is what that represents, you need to put the area to the left of that boundary and into the function I and v norm. So the lower boundary is I and v norm, and you're going to put in the area to the left, which is 5%, but we have to put it in as a decimal, 0.05, followed by the mean. Now, it doesn't matter what mean or standard deviation is listed in the problem. When you're finding a critical value, it is a z-score, so you have to use the standard normal curve. So the mean is 0 and the standard deviation is 1. and we get negative 1.645. I usually go out to about 3 decimal places for critical values. Now, let's do the upper boundary and see what we get. So the upper boundary would be INV norm, and we want to put the area to the left of it. Well, the area to the left is the 90% and the 5% together, so that's 95% or 0.95. When we put this in our calculator, we will get positive 1.645. What you're going to find when you do these, if you were to do both the left boundary, the lower boundary, and the upper boundary, is it's going to be the same number, but they're going to be opposites. One's negative and one is positive. So really, you only need to find one, and then your critical value is just going to be the positive version of that. So a lot of times what I will do is I'll find out what this lower percentage is, 5%, put that in, and then take the negative off, and that would be my critical value. So 1.645. So now let's find the z-score for 98%. So actually, why don't you pause the video and you can find that, and then come back and we'll go over what the answer is. Okay, if the center is 98% or 0.98, that leaves 2% left over for the left and right, and if I split that in half, that's 1%, which is the same thing as 0.01. So for the lower boundary, I'm just going to do one of them. INV norm 0.01, and then 0.1 for the mean and standard deviation. And then if I put that in my calculator, I get negative 2.326. Now, you are welcome to do the upper boundary. If you put in the upper boundary, the area to the left of the upper boundary is 0.99, 99%, and you're going to get positive 2.326. It's always going to be the same, but opposites when you're finding the critical value. So you can find either one, as I said. So in this case, the critical value is positive 2.326. Okay, so we're going to stop here, and we're going to pick up with example 5 in the next video.